Which asteroids could actually destroy Earth? Some could erase a city before you finished your coffee. One could end almost everything alive, and the most dangerous one is the one we never see coming. Start small. February 2013. A rock the size of a house slammed into the sky over Russia. It was about 20 meters across. It came from the direction of the sun, so no telescope on Earth saw it arrive. It exploded miles above the city of Chelyabinsk with the energy of roughly 30 Hiroshima bombs. No crater, no warning, just a flash brighter than the sun, then a shockwave that shattered windows across 6 cities and injured over 1,500 people, most of them cut by flying glass while standing at their windows. A rock too small to track did all of that. Now we climb. Most space rocks are dark. They reflect almost no light. A dark 20-meter asteroid is essentially invisible until it is already burning through our air. And here is the part that should worry you. When one approaches from the direction of the sun, our telescopes are looking straight into glare. We are blind in exactly the place an asteroid is most likely to hide. Chelyabinsk wasn't bad luck. It was a preview. 20 meters is the low rung. Objects this size hit Earth every few decades. They rarely reach the ground. They burst high in the atmosphere, and the air itself becomes the weapon. A shockwave, not a crater. Annoying on a good day. Deadly on a bad one. Keep climbing. Now 50 meters. In 1908, something around this size exploded over Tunguska in remote Siberia. It flattened 80 million trees across an area larger than a major city. 2,000 square kilometers of forest knocked flat in an instant. If that object had arrived a few hours later with Earth's rotation, it would have erased a European capital. 50 meters is no longer a window breaker. 50 meters is a region killer. And we still climb, 100 to 300 meters. This is the range scientists quietly call the city killers. An object this size doesn't burst in the sky. It reaches the ground, it carves a crater. The blast, the heat, the air blast spreading outward would destroy a metropolitan area completely. Millions of people live inside a single one of these footprints. We know of thousands of asteroids in this class, and we have not found them all. Higher still, 1 kilometer. Now we leave the local and enter the global. A 1-kilometer asteroid hitting Earth doesn't just destroy a city or a region, it throws so much dust and debris into the atmosphere that it dims the sun. Crops fail across continents. Temperatures drop. This is a civilization-threatening impact, the kind that doesn't kill you with the blast, but with the years of cold and famine that follow. The good news? We found most of the kilometer-class asteroids near Earth. The bad news is in the next rung, 10 kilometers, the top of the ladder. 66 million years ago, an object roughly this size struck near what is now Mexico. The impact released more energy than billions of nuclear bombs. It ignited the sky. It sent a tidal wave across an ocean. It buried the planet in darkness for years, and it ended the dinosaurs, along with most life on Earth. This is extinction scale, not a disaster. An ending. There is nothing above this rung. There doesn't need to be. So which of these could actually destroy Earth? The honest answer is that the small ones are the ones we should fear most, because the small ones are the ones we can't see. The extinction-class rocks are big, bright, and almost all already mapped. The city killers are dark, quiet, and still hiding. And the ones coming from the sun's direction are nearly impossible to detect from the ground at all. This is why early detection is the only real defense. Not weapons, not heroes, telescopes. Surveys that scan the sky night after night, cataloging every faint moving dot, calculating where each one will be decades from now. The entire game is finding the rock early, because time is the one thing that changes everything. Picture an asteroid we spot 20 years before impact. With 2 decades of warning, we don't need to blow it up, we need to nudge it. A spacecraft striking it years in advance changes its speed by a tiny amount, and that tiny change multiplied across millions of kilometers, makes the asteroid miss Earth entirely. We've already tested this. In 2022, a NASA mission slammed into a small asteroid and measurably changed its orbit. Gentle, early, and from far away. That is how you actually save a planet. Now picture the opposite. We see the rock with only weeks to spare. People imagine a nuclear missile and a brave countdown. The reality is far worse. Blowing up an asteroid at the last second can turn one large impact into a shotgun blast of radioactive fragments, several of which still hit Earth. Last-minute nuking is not a plan, it's a panic. The deflection that works is the one you start years ahead. So everything comes down to time. Time to see it, time to measure it, time to push it. With enough warning, almost any asteroid on this ladder can be stopped. With no warning, even a small one wins. Earth sits alone under a vast black sky. Surrounded by millions of dark rocks, we have only begun to count. Time is our real protection. And the asteroid we cannot stop isn't the biggest one. It's the one we see too late.